Okay, so what we're going to be looking at here is the distance between 2 points. And I think this is something that you're probably familiar with from GCSE, but like I've said before, we want to make sure that everybody is on the same page here. So I have said, recall this little triangle is actually a Greek letter, this triangle, and you call it delta, and we used it before, and it means the change in, okay? It means the change in. And I have got an example here of two coordinates. This coordinate is 1, 6, obviously 1 along and 6 up. And this one is 5, 9. It's gone from the origin 5 along and then 9 up. And we want to find the distance between these 2 points that we've got here. So the x-coordinate at this point is 1, and the x-coordinate at this point is 5. So how much has it changed? What is the change in x here?
4.
It's just 4, okay? And the y-coordinate at this point is 6, and the y-coordinate at this point is 9, so the change in y is just 3. Now, if I was to draw this triangle again as a sketch, where there's 4 here and 3 here, and they must be a right angle because obviously the x direction and the y direction is a right angle. And the question was wanting us to find out the distance between them. What area of maths would we use that would help us find out that distance? Pythagoras. Okay, so this whole thing about finding the distance between 2 points is going to be based on using Pythagoras, okay? So for this particular question, the distance would be equal to the square root of 3 squared plus 4 squared. And this is a really famous triangle because the answer is 5. So this is one that's going to come up time and time and time again in maths. You will always see a triangle that has 2 of the sides are 3 and 4, and the third side of the right angle triangle will be 5. It's called a Pythagorean triple, which is 3, 4, 5. I'm just going to draw this one in, 3, 4, 5. Does anyone know any other famous ones that have got integers as the side? Because sometimes with Pythagoras, so you could have the same as this one. You could have the same ratio as this, where you could double all of the sides. So you could have 6, 8, and 10. But I'm trying to find ones that aren't similar triangles. I just want to know if you know any other Pythagorean triples.
12, 5, 13.
Good, good. 5, 12, and 13 is one of them. And there is one more that I can think of, which is 7, 24, 25. Now, the reason I'm bringing these up is because they pop up quite a lot in maths, because most other triangles don't have 3 sides that are integers. And if they don't have an integer side, when you do the square rooting, you're going to have a... Yeah, but what was the word that we used when we studied this a couple of weeks ago? A surd. You would have a surd. So these triangles are kind of interesting because when you do square roots when you square, add, and square root, you don't get a surd, you get an integer number. So you'll find these ones popping up a lot, but they're not going to pop up all the time. So I've written down here that the formula for finding the distance between the 2 points is the change in x squared plus the change in y squared, all square rooted. So the distance between these 2 points is just a variation of Pythagoras. And Pythagoras now, you'll start to see how it's not just about triangles. Pythagoras is about loads of things. It's now about the distance between 2 points. It's going to come up lots and lots and lots, okay? And there's something I wanted to point out. Here, the change in x, we kind of just got a feel for it. We just decided that the difference between 1 and 5 was 4. Now, this is going to sound really stupid, but I just want you to tell me, how did you know that the difference was 4? And I know it's a stupid question.
5 minus 1.
Okay, so you did 5 minus 1. Would it have mattered if you did 1 minus 5? Would it?
Not really, not to the answer.
Not to the final answer. Not to the final answer. Because if you did 1 minus 5, you would have got negative 4. And why won't that matter for the final answer? Pardon? Because it gets squared, okay? And if you square a negative, you're still going to get the same answer to it. So later on when we do some of these questions, just find the difference between them. I don't care if you do this one, take away this one, or this one, take away this one. It's not like the gradient where the order mattered. For the distance between the 2 points, you just want the change, but you just want the difference between them. And so you should always try and do the difference that just gives you the easiest number, because it's going to be squared anyway. Okay, so that's something just to point out at this stage here. It's different to gradient, where you do need to subtract them in the right order. With distance, we just care about the gap that is between them, okay? So I said this in the note. Unlike with gradient, we don't care if the difference is positive or negative because it's being squared anyway. So I'm going to do these three really quickly to find the distance between. And I'm not going to do how some textbooks might do. They might say, oh, the change in x, don't write this down. They might say, okay, it's going to be 7 minus 4 squared. That's just silly. We don't need to do that. We're all better mathematicians. We can just look and say like that the change in y, there, was 7 and 4. We can just say what the change is between them. So the difference between the x coordinates here is just 2. The difference between the y coordinates is just 3. So we have 2 squared plus 3 squared, which is 13. So the distance between those 2 points is the square root of 13. Roughly, what is the square root of 13 if you were going to put it in a calculator? Between 3 and 4. It's probably like a 3-point something. Just so you get a rough idea of what this might look like, it's got a gap of 3 between them. Okay, so this second one that we've got here, what's the gap between the x's? And what's the gap between the y's? 4, good, because it's 1, take away, -3. The gap is actually 4 between those. So you get 1 squared plus 4 squared, which is root 17, okay? Root 17 here. And now we're going to think about the distance between these points that we've got here. Sufyan, what's the difference between the x coordinates?
-1.
Yeah, we could say -1. I'm just going to say it as 1 because I know it's going to get squared in a second anyway. By the way, if you were going to say -1, you shouldn't write -1 squared. What should you write? You should write -1 all squared. But for me, that just feels like a waste of time. So I'm just going to do 1 squared instead. And what's the difference between the y's, Abdi?
Is it 5?
It's 5 because you've got you could either do -2 -3, or you could do 3 minus -2. So the overall distance is 5. And what is the square root of 1 squared plus 5 squared?
Square root of 36.
So it's root 26. Can root 26 be simplified? No, it can't be simplified. None of these ones can be simplified here. So you've got 3 quick questions to do. I think you're going to have a minute to do these. So we don't need any talking, really. You can just do those 3 at the bottom. Okay, about 15 seconds more.
What's the differences between -12 and -4? 8.
So you can either think of a number line, or you can just subtract them. So you could do -4 minus -12. What would that be?
Plus 12.
So it's -4 plus 12?
8.
8. So the difference is 8. Okay. Zakia, what did you get for the first bit of the working out for this one? The difference between the x and the difference between the y?
Square root of 4 squared plus 4 squared.
Careful, 1 and 4, the difference is 3. So you get 3 squared plus 4 squared, which is?
25.
Good, so it's the square root of 25, which is 5. Okay? Minhaj, what did you get for this second one that's here?
-3
So you got -3 squared, yep,
and then 2 squared.
and 2 squared. I probably would have, if you ever see you get -3, just write it as 3 squared. It's not going to matter, and it'll make the whole thing just look a little bit easier for our brains to process them as well. So we've got, what is the -3 squared plus 2 squared going to simplify to?
13.
Root 13, yeah. 9 and 4 is root 13. And then, Lily, can I ask you what you got for this last one here? What you got as the difference between the x?
8 squared
Good.
and 6 squared.
8 squared and 6 squared. And what does that give you?
Root 100, which is 10.
Good. Root 100, which is 10. So this is actually This is one of the Pythagorean triples that was mentioned earlier, but I didn't write it down. Why did I not write it down earlier? Why didn't I write it down earlier, Andrew?
It's just b 3 squared plus 4 squared.
Oh, yeah.
It's the same as this triangle, but it's 6, 8, and 10. Because it would be silly for me to write down like 30, 40, and 50, or 3,000, 4,000. I mean, I'd just keep writing them down forever. So you can have similar triangles, which means they're the same but multiplied. And I'm going to just come up with one other kind of question now that we're going to have a look at together. So I'm going to say I have 2 points, and my 2 points are 1, 7, and A and 2. And I'm going to say the distance between them is 3 root 2. Is that going to work? Yeah. I hope so. Find the possible values of A. So this time, I'm just going to, I've given you some of the information and I've removed some of the other kinds of information. So we're going to see if we can come up with just a slightly different version of this problem. Okay, so I now know that the distance, which is 3 root 2, is the square root of the difference between the x's plus the differences between the y's. So the difference between the x coordinates is going to be what? 1 minus a, and then it's all going to be squared. Or a minus 1, whichever one. Which one do you think we're more used to seeing? 1 minus a or a minus 1?
A minus 1.
I prefer a minus 1, so I'm going to go with a minus 1. And I'm going to put it in brackets like this, a minus 1 squared. And then the difference between the y coordinates is 5. So I have 5 squared. I think I might actually change this. Instead of it 3 root 2, guys, would you just change it to 5 root 2, please? Otherwise, I think I might have created an impossible question. Okay? So how am I going to solve this equation to try and find out what a is equal to?
Let's find the original thing said,
I don't know what that means. Find the original third. What do you mean?
as in the first simplified from 5 to 2.
I could do, but you can use this on a calculator. So there's something that's kind of in the way of this hand. How do I get rid of what's going on the right-hand side here? What do I need to do? I need to square it. I've got a square root there. I want to get rid of it. So I'm going to square both sides. If I square this side, I'm going to do 5 root 2 times 5 root 2, which is how much?
10 root 2. 25 to the 50.
It's 5 root 2 times 5 root 2. So that's 5 times 5, which is 25, times root 2 times root 2.
50.
So it's 50.
Yeah, it cancels out the side, right?
Yeah, so the root 2 times root 2 is just 2. So you've got 2 times 5, which is 50. So this is 50, because that's 5 root 2 squared. And I've just got rid of the square root sign here. So it's just a minus 1 squared plus 25. Okay? Now, to solve this equation, there's lots of different ways you could do this. I want to know a suggested way, and I'll tell you whether I think it's the best way or not. Anyway, that's the best way to do it, okay? The bad way to do it would be to expand the brackets here, because you've only got a single a by itself. If you expand the brackets, you're going to have an a squared, and you can have an a, you're going to have an annoying quadratic. So we're going to take away the 25 from both sides. So we get 25 equals a minus 1 squared. And now what should I do to both sides of the equation? I should square root it. Now, if I square root this side, I could have the positive and negative version of it. And if I square root this side, I just get a minus 1. So this is going to be plus or minus 5 is equal to a minus 1.
Plus 1.
And then I plus 1. So I'm going to say that a is either equal to 5 plus 1, which is 6, or a is equal to minus 5 plus 1, which is minus 4. So this is why there were 2 possible values that this could be, that this could happen. Okay, this is why there's 2 possible values. Okay.
Where did you get the second 5 root 2 to make it 50?
Because from this line to this line here, I'm squaring. That's how I got rid of the square root sign. So I'm actually doing this all squared, 5 root 2 all squared is 50. And you can use the calculator to confirm these things as well. So I'm just going to really quickly do a sketch of what's happened here, because this is what the algebra tells us. The algebra tells us that there are 2 points that it can be. But we want to try and think about what the geometry of this situation is. We want to try and think about why are there 2 possible values for A. Surely there should just be one place that it can be. So if I just do a very quick sketch of what's happening here, everything's positive, so I can do it a bit more like this. And we've said that one of the points is 1, 7 up here. And the other point is A2. So we don't quite know where it is, but we do know that the y coordinate is 2. So we know it's going to be somewhere over here. It's going to be somewhere along this line. Now we want the distance between this point and somewhere along this line to be 5 root 2. So why do we think we've got these 2 different answers here? What? Yeah? We're trying to say the distance from here to the line has got to be 5 root 2. So why are there 2 places instead of just one place? Lily? It's because it's a quadratic. Yeah, but what will that look like when we put it on the graph? It's not going to look... No, we're not drawing a quadratic. I suppose what I'm really trying to say is to be 5 root 2, from this point, it could either go over this direction, and that distance here could be 5 root 2, or it could go the other direction, and it could still have a distance of 5 root 2. So the coordinate here, which coordinate do you think this one would be? Good, this is the 6. This one is 6, 2, here. But it could have been over here, which has minus 4, 2. So there are 2 different places. That's why there are 2 answers, because the distance between these 2 points could be in 2 different places to still give that distance of 5 root 2. And that's the kind of extra sorts of questions they might like to ask you about this, where the information is kind of hidden within the question instead. Okay? So we're going to then push this on to looking at some other things as well. We're going to be looking at some area of shapes. I think we did a question like this that was relatively similar. I think we might actually have even done this question. So we'll do it as a bit of a reminder, and then I think we'll be at a point where we might do some practice. So this one says that the diagram shows 2 lines with equations y equals 3x and x plus 2y equals 4, which intersect at the point P, and we want to determine the coordinates of the point P. Now, we've done this before, so I'm going to do this one relatively quickly, but what do you think I will need to do with these 2 equations that I've got here to find the intersection point? Solve them simultaneously. And what's the best way of solving this simultaneously? Substitution. So I'm going to substitute, instead of y, I'm going to put 3x. So I will have x plus 2 lots of 3x equals 4. I've substituted y equals 3x into here. So that becomes 7x equals 4. So x equals 4 over 7. But that's not the coordinates, that's just the x coordinate. How would I find out what the y coordinate is?
You sub that
Into what?
into the y equation.
Which y equation?
Y equals 3x.
I agree, this is the easiest one to do. So I'm going to substitute the x into here. So it's going to be 3 multiplied by 4 over 7. 3 times 4 from the numerator is just 12 over 7. So the coordinates of P are the x coordinate and the y coordinate. Okay? And then part B of the question says that the line x plus 2y equals 4 intersects the x-axis at the point Q. Determine the area of the triangle OPQ. Well, they've kind of asked us 2 things. They want us to find the area, but they have also said to us that it intersects at the point Q. Remind me, if it's intersecting the x-axis, what do we know? So y is equal to 0, and they're talking about this line here. So we have x plus 2y equals 4. So what's x equal to? 4, because y is 0. So you just get x equals 4. So the coordinates of Q are 4, 0. And I'm just going to add that on the diagram that this is 4, 0. I actually think we talked about this question as well. And it wants us to find out the area of triangle OPQ. So that is OP Q. We want to find out the area of the triangle that we have in here. Now, I was doing this with my year 9 group who find stuff like this kind of difficult. So I'm hoping you're going to be able to remind me. The area of a triangle is? Base times height divided by 2. Now, often people think that they need to be, that you need to have it like the way around it is now. You could also have triangles on the side as well. So for this triangle that we've got, for triangle OPQ, we're going to have a half, which is the divide by 2 part. What's the base of this triangle? 4. Good. The distance from here to here is 4. And the height of the triangle? 12 over 7. The p coordinate is 4 over 7, 12 over 7, which means it's 4 over 7 to the right and 12 over 7 up. So 12 over 7 is the height of the triangle. So you've got a half times 4 times 12 over 7. So a half of 4 is 2. 2 times 12 over 7 is 24 over 7 units squared. I think we actually did this before, but it's a good recap now that we're kind of back on this sort of area of things. You don't have to write unit squared. The reason I write unit squared is because it could be, if the question changed to centimetres, then this would be centimetres squared. If it changed to metres, then it would be metres squared. That just tends to be how we write those bits that we've got there. So in the next exercise that we look at, there's going to be some things to do with the distances between points, but they might also ask you about the area of shapes and the area of triangles. They could, if they wanted to, have asked you about the area of this triangle that you've got here. In this case, what would be the height of this triangle? We don't actually want to work out the number. I suppose I can't really answer this question. We could call this the base of the triangle, and then we could call the x coordinate of P, that could be the height of the triangle. You could kind of rotate your vision to think about it, as long as the base and height are perpendicular to each other. So this one is going to be slightly different again. They like to have 2 lines on these equations. And we're going to try and find some different areas in just a moment. But the first thing it wants us to do in this question, we've got these 2 equations. We've got 2y equals x plus 4 and x plus y equals 8. And the first thing it wants us to do is to find out the length of PQ. So before I can find out the length of PQ, what needs to be done? Minhaj, what would you do first to try and, if we're going to try and eventually find out the length PQ, what else needs to be done before I can get there? Find out where P is. How am I going to find P? And how do you find out where the 2 lines cross?
Subtract the
What's it called? You need to do simultaneous equations, okay? Not midpoints, not the equation of a line, simultaneous equations to find out where P is here. And I'm also going to need to find out where Q is. How am I going to find out where Q is? The intercept. So I'm going to find the y-intercept, which is found by doing what? Well, I've got the equation of the line. How do I find the y-intercept? I don't want to keep going back to y equals mx plus c. What is? No, I've already got it here. What's true about this point here? Good. X equals 0. It's more sophisticated to say x is equal to 0 than to try and make it look like GCSE y equals mx plus c. It is so much quicker for this to just say that x is equal to 0, and that will tell you what the y coordinate is.
So y equals c because m times 0.
Yeah.
Is 0.
That's why it works. That's why c is c in y equals mx plus c. But it's much better here just to substitute in the value that you need. Okay? So let's begin by finding out what P is. So we're going to do simultaneous equations. I have that 2y equals x plus 4 and x plus y equals 8. What do you think is going to be, what would be your way that you might try and solve these simultaneous equations? You would times by 2. I perhaps probably wouldn't do that. I would probably do some substitution. I just prefer to do that. I think you'll find in A-level it's going to be a bit better to do. So I'm just going to take this one and I'm going to rearrange it to make either x or y the subject.
So y equals 8 minus x.
Good. Okay, so why don't we make y the subject? It doesn't really matter. Y equals 8 minus x. And then I can take this and I can substitute it in here. so that I get 2, instead of y, it's going to be 8 minus x equals x plus 4. Expanding the brackets, 16 minus 2x equals x plus 4. And then I add 3x to this side, 2x to this side. So I get 16 equals 3x plus 4. Then I'll take away 4. And then I will divide by 3, so that I get x is equal to 4. And if I know that x is equal to 4, how should I find out what y is equal to?
So then 2i would equal 4 plus 4.
But isn't there a quicker way of finding out what y is equal to?
Minus 4.
Yeah, look what I've got written here, Abu.
Oh, yeah.
I've got 8 minus x, so it's just going to be 8 minus 4, which is 4. So all of this information tells me that p is 4, 4. All that work was to find out what p was. But the work to find out what q is going to be a lot quicker. Because we said to find out what q is, we make x equal to 0. You just need to make sure you're using the right equation. Which is the equation that it's going to be using? 2y equals x plus 4. 2y equals x plus 4. And we know that x is 0. So 2y is 4, which means that y is 2. So q is 0, 2. I'm going to add this to my diagram. So this is 0, 2, and p is 4, 4. So good. We're now going to do the distance PQ. Now, instead of writing distance now, I can actually just write PQ. If I write 2 letters next to each other like this, as long as they're capital letters, this means the distance between those 2 points. Okay, that's what it means when I say PQ equals. And it's going to be the square root of the difference between the x's. What's the difference between the x's? 4. And the difference between the y's? 2. We've got 2 and 4. The difference between that is 2. So it's root 16 plus 4, which is root 20. And root 20 is the same as 2 root 5. And remember, you can use calculators if you find you're getting a bit slow with some of these things. Okay? So the distance PQ is 2 root 5. Do you see how there's not necessarily anything that's new here, but there is definitely a lot more being asked of you? They're asking you to do a lot more work here to be able to come up with these answers. And for the next part of the question, it says that we are trying to find the area of PQR. It doesn't even tell us it's a triangle, but when we've only got 3 letters here, it's obviously going to be a triangle. So I've got PQR. And so we have a triangle. The area of a triangle is base times height divided by 2, or a half base times height. And I've said inside this tip box that when finding areas of triangles in exam questions, or just any time, one line is often going to be vertical or horizontal. And so you should generally choose this to be the base of your triangle. So in this case that we've got here, I'm kind of rotating my head so that I see that this bit here is the base of the triangle. And so that the height of the triangle is going to be this distance from here to here. So all the information is kind of available, but you just need to make sure that you're extracting it and finding the bits that you need. So what do we think this distance is from P to the axis?
4.
4. How can you tell that it's 4?
Because P is equal to 4, 4, which means the x-axis is 4 minus 0, which is 4.
Yeah, so the fact that its coordinate is 4, 4, it just means that it has moved 4 across in that direction. So that section needs to be 4. Now, I don't know what this distance here is, QR. How can I find out the distance QR? Pardon? I think making x equals 0 is so easy to make that. So we're going to try and find out the coordinate of r. And to find out the coordinate of r, I'm going to make x equals 0 for this equation, which is x plus y equals 8. So what's y equal to? 8, okay? So this is now 0, 8. Do you see how the diagram also becomes a really useful tool because you can keep filling information into it to see what's happening? And so the distance between Q and R is 6. We don't need to do any of the squaring or anything because we can just see 0, 8 and 0, 2. The distance is 6 between them, and we said this distance here was 4. So QR was 6. And so the area of PQR is a half times the base times the height, which is 12 units squared. I think each individual part of this question, if I told you, do simultaneous equations, make x equals 0, do Pythagoras to find the point, I think each of those individual things, everybody in the class can do all of those individual things. I think what you will find more challenging is nobody telling you, do this, now do this, now do this. You have to stop and look and say, what do I need next? How can I find it? And actually keeping track of what you're doing. So I'm going to ask you to have a go at doing one of these yourself now. So this time I've got two different equations. I want you to find the coordinates of P. Then I want you to find the area of PQR. And I also want you to find the length PQ that you have here as well. So I'm going to give you a couple of minutes to get started. And then I'm going to just silently do these answers so that we can check over them in a second. And then we're going to do some questions from exercise 5G. So I'm going to give you a couple of minutes before I start doing any work. If you've got any questions.
Y equals